Okay, so now let's see, return to that, we're looking at that same graph that we just made. Does it have an x-intercept? So we kind of already talked about this. This one is not going to ever touch the x-axis. If I multiply by 1/2 and 1/2 and 1/2 and keep going, I will never actually reach 0. I will get so close to 0, but it will never actually touch the x-axis. Okay, so they're having us complete it for some big values. So these are, I'm just going to put these in decimal form. If you did them, so that would be 0.5. That's the same as, so that's a half. This is 1/8. Okay, 0.03125. This is each one just doing 1/2 to the 5th, 1/2 to the 7th, 1/2 to the 10th. So you can see it getting drastically smaller. And if I go out even more, even just a couple more times, then it's going to get smaller and smaller. Okay, but it will never actually, they're getting close to 0. Okay, what happens as it gets larger, it gets close to 0. But does it touch it? It does never touch it. So this does have, we've talked about this last time, a horizontal asymptote. So the graph approaches the x-axis, which is what makes it an asymptote. It never actually gets there. Okay. The actual asymptote is the line y = 0. That's our actual horizontal asymptote. Okay, so let's see what this one wants us to do. So we're just going to kind of list a couple things for each one of these. So if we have h of x equals 1.08, so this is, the base is, 1.08. Okay, so this one is a growth. Okay, so the x-intercept, these are not going to have any. But the y-intercept, if I plug in a 0 for x, this is going to come out to be 1. Okay, it's going to have the same, all these exponential ones are going to have the same horizontal asymptote. And since this is a growth factor, this is going to be increasing. Okay, so the next one, 0.75 is our base. It's less than 1, so that's decay. And this is all going to still be the same. Okay, if I plug in a 0, it doesn't have an x-intercept. If I plug a 0 in for x to find my y-intercept, I still get the same 0, 1. It still approaches the x-axis but doesn't touch it. And this would be decreasing because it's a decay factor. Okay, so I'm just going to fill in these next two. So I would stop the video for a second. I'd fill in these next two and then turn it back on and see if you have the same thing as me. Oops. Okay, so hopefully you get the same thing there. They pretty much have very similar characteristics. It's just a matter, you know, a growth is going to be increasing, a decay is going to be decreasing. So without graphing, how might you determine if it's increasing and decreasing? Well, we just said that depends on B. If it's either growth or decay. Okay, so let's see what we got these last couple ones. So this one is just, we don't know the growth factor or the decay factor. It's just looking at each one for this, determining if it's linear or exponential, and then determining if it has a slope, if it's linear, or if it's growth or decay. So if I'm looking at each one, I'm really looking at, to decide if it's linear, I'm looking if there's a constant rate of change. So for example, this one right here, this goes up 3 for every up 1. So we have to see if that's consistent. That is going up 3 for every up 1. Up 3 for every up 1. So this one is linear. And I just found that slope, which is 3/1. Okay, this one now, let's see what's happening. Let's just look if there's a slope. So this is going up. Oops, sorry. Let's erase that. This is going down 6, and this is going up 1. So let's see now. This was going now down 2 for up still 1. So I don't care about the 6 and 2 being different if it reduced to the same thing. But this is definitely not linear. Okay, so then I have to kind of just look at now, all my x's are going up by 1. So that's a good thing that for us to try to figure out what's happening, because I don't have to worry about skipping x's. So now I'm just looking at the y. So look at the first one. If I know this is not linear, I'm now looking for a common factor. So from 9 to 3 to 1 to 1/3 to 1/9. First of all, we know it's decreasing. So it must be a decay factor. And the decay factor would be 1/3. Okay? To get from 9 to 3, I times it by 1/3. From 3 to 1, I times it by 1/3. From 1 to 1/3 times by 1/30, and that's consistent. Okay, so I'm going to stop right there. Let me just turn the slide, just give you the answers here. You're going to fill in the rest of the chart just by the first two. They're telling us it's exponential. If they told us it was linear, if they didn't tell us and we weren't sure, we wouldn't be able to fill in the rest. But you go and try to find that decay factor by the first two. Okay, and I'll give you the answer just so after you fill in everything you can see if you get it right. So that would be, my B would be 1/4. That's the only thing that would get me from 16 to 4. So you have a nice little summary here that went over everything we just did. And then the next activity that we do is just going to really pick up right on this one and talk about if that horizontal, or that vertical intercept is not always 1. So how does that happen? What does it look like in the equation if it's not 1? Okay?